Assalamu alaikum and welcome to lecture number 19 of Software Requirements Engineering CSE305. And in today's lecture we are going to continue our discussion on the negotiation process, and we are going to then start our discussion on the specification process. And if you guys remember that we started talking about negotiation in our last lecture, and we tried to figure out that as a process what are the different activities involved in the negotiation process. And specifically we looked at requirement prioritization, which is one of the very key activities when we talk about the negotiation process. We are going to finish our discussion on this process, and then we'll talk about the specification process. And as we know, when we talk about specifying requirements, then what that actually entails that we are talking about writing functional requirements and writing non-functional requirements. So we're going to have a look at that. We very briefly we have discussed. I've shown you guys a template of a sample project where the requirements were mentioned, and we discussed some of the functional and non-functional requirements. We are going to go over that again and have a look at how these requirements are written once again. And if you guys remember, we discussed very briefly that what are the general guidelines when we are specifying requirements. For example, one of the things that we said was that we need to use templates, and there should be a standard template, and each organization should adapt a template and then customize it according to their particular context. And context means, you know, what type of projects they are doing, what kind of information their client wants, and specific to their domain or specific to their area, they need to customize it. So this is what we have now we are going to talk about in today's lecture. This is what we have in store today. So let's quickly recap. You know, as I said, that we talked about the negotiation process, and we talked about what are the activities involved in the negotiation process. And keep that definition of the negotiation process in mind. For example, as we said that, you know, each process is nothing more than a set of activities. So we have some activities, and these activities, we perform these tasks in order to achieve something. And the first thing maybe that we do, or the very important thing that we do at negotiation, is requirement prioritization. And as we know that why we need to prioritize these requirements, we have talked about these things, that how negotiation comes into play and why it is important. We have said that when we analyze and elaborate requirements, we identify lots of problematical requirements or lots of ambiguities in the requirements. Because we have now more understanding about the requirements, we are in a position to go and discuss with the client. Because everybody, we need all the stakeholders to be in consensus. So everybody, we need to reconcile all the requirements. So but there can be lots of these problematical requirements, so we need to prioritize these requirements. And we said there are two main purposes of negotiation. One purpose of negotiation is to resolve those problematical requirements. The other purpose is to identify that which features or which requirements or in which order we have to start building the project. So depending on the purpose of this requirement prioritization, the different parameters would be changed, and you will get a different rank of requirements. And we said we looked at different requirement prioritization techniques. For example, we said a very simple criteria of prioritizing requirements is that for example, you have stakeholders and you have domain experts, or let's say you have multiple stakeholders. So what you can do is, for example, and we have these three requirements, R1, R2, R3, and we have a scale where we say low, medium, and high. So what you can do is we can ask our stakeholder one that, you know, how does he prioritize this particular requirement. So for example, stakeholder one says that R1 is high priority, R2 is medium, and R3 is low. And our domain expert says no, R1 is medium, R2 is high, and this is low. And then S2 also says that, you know, this is medium, this is high, and this is low. Now, if we look at these three particular requirements, then R3 we do not have any problems, because everybody agrees that this is the lowest priority requirement. But there is a slight conflict when we talk about R1 and R2. So these things are problematical, and sort of, you know, because different people can come up with different prioritizations, we need to reach a consensus. We need to make sure that the rank that we have of requirements, everybody agrees to it and everybody is happy with it. So once we do a requirement prioritization, then the next thing is that we try to identify all the risks associated with each requirement. So that was the next activity, that we try to identify all the risks associated with each requirement. And why this is helpful? Because the next task is to analyze the impact of each requirement on time and cost, because these two are very important project variables. And if you guys remember the triple constraint diagram that I've been discussing with you guys, that we have scope, time and cost, and when we are gathering requirements, so we are dealing with scope, but we need to, and as a project manager, what usually happens is that you need to strike a balance between scope, time and cost. So as a requirement analyst, when you are gathering requirements, one of your jobs is to understand or give an idea, okay, so what is the impact of this particular requirement on overall time and cost, because this scope is actually translated into these two values. If scope becomes too big or you overscope, then you're going to spend too much time on it, or you're going to spend too much money on it. So you need to strike the balance, and you need to figure out, okay, this, for this particular requirement, this has this kind of impact on time and cost. So you do an impact analysis of each requirement. Then finally what you do is that you try to reconcile, and you start a reconciliation process. So this is kind of an iterative process which we call reconciliation, and this is, you can call it a sub process of this negotiation process, because reconciliation is iterative. Because what we do is that one of the techniques that we do when we do this reconciliation process is that we have negotiation meetings. So the next thing that we discussed was negotiation meetings, and we talked about what do we have in these negotiation meetings. These negotiation meetings, they are normally divided into different phases. So normally the first thing that you would do as a negotiator is that you would put everything on the table. So you need to discuss everything. So not discuss, actually you need to present the problems. So you need to present the problem to all the stakeholders involved. For example, I have identified that this particular requirement 1 and requirement 2, there is a conflict between these two stakeholders. So stakeholder 1 says that R1 is high priority, and stakeholder 2 says it is of medium priority. And we need to figure out which feature to be done first. So what we'll say, okay, we'll have them sitting together. We'll say, okay, we have a problem here, and we need to discuss the solution. So you present your point of view, that why do you think it's a problem, and then you give a chance to all the participants. So for example, stakeholder 1 and stakeholder 2, what they would do is they're going to give their opinion, that why they think this thing is of high priority, and stakeholder would try to defend that why he thinks that no, R2 should be done first. So you get their opinion, and then you give them a chance to, then actually this process begins, where you try to resolve this particular conflict, where you try to reach a consensus. And there are three possibilities here when you have these kind of conflicts. Either you change or you modify a particular requirement, or you delete a requirement altogether. So for example, you delete it, and the third option is that you do more elicitation. So you go back to your elicitation process, and you say, okay, initially maybe we didn't actually spend too much time on getting this requirement and understanding this particular process. So we need to maybe spend more time on elicitation. So this is how this whole process works. And in our last lecture, we also talked about some of the techniques of requirement prioritization, and there have been lots of work done on requirement prioritization, and I told you that there are lots of techniques out there. Recently, there's a paper published in Information and Software Technology Journal, which is a literature review of all the requirement prioritization techniques, and it has almost 40 requirement prioritization techniques. And if we try to look at that those different techniques, and the way I would want to look at them is that how usable are those techniques. And there are lots of pros and cons of different techniques. If a technique is too simple, for example, the one that we discussed down here, that is a too simple technique. So it maybe is not a solution to all the problems. But there are techniques which are too complex. For example, the techniques based on artificial intelligence, maybe they are too complex. There are also some problems with some of the techniques that they cannot handle too much requirements, because it would mean that they would take too much time to come to a conclusion. So it's still a problem. So despite these 40 techniques which are out there, requirement prioritization is not a solved problem, because the way practitioners actually do it in industry, and that is something which I discussed in the last lecture as well, that people do not follow any of these prioritization techniques as such. They would do they would do this kind of ranking, but that also stays with the people. So that is kind of tacit, and they kind of discuss it, and it is not explicitly put anywhere that this is the process through which we are going to prioritize or rank our requirements. So there is still a gap between what the practitioners want and how we academics try to solve this particular problem. So we need a solution that is usable, is simple, and which is adaptable as well by different contexts and different size of requirements. So this is what we discussed in our last lecture. And in today's lecture, we are going to just look at this negotiation process and just try to get what where we are with the overall software requirement engineering process when we talk about negotiation, and then we will start looking at the specification process, and specifically within the specification process we are going to look at how do we write functional requirements. So as we said that negotiation is about a reconciliation. So during negotiation, the software engineer reconciles the conflicts between what the customer wants and what can be achieved given limited business resources. So this is really important. This last bit of this slide is very important, which says that limited business resources. So we need to emphasize on that imagine that if we are given enough time and enough money, or a lot of time, a lot of money, and there is no boundaries on it, then we will never be able to finish the project. So that's why normally every project is usually bound by, not only bound by scope, it is also bound by time and cost. We are given those limited resources because if we are not given those limited resources, we are not going to do anything, and we will just sit idle, and we're saying, okay, there is no time limit, so let's do it tomorrow, and we'll just keep on postponing that. So normally every project we have some limited resources, and we have to finish that project within those limited resources. And this is where negotiation comes in. That negotiation is not just about resolving those problematical requirements, it is also about trying to convince the client that this particular thing cannot be done the way you want it to be done. So basically it's kind of not only negotiating between different stakeholders or between different end users, but it's also negotiation between you and the client. So this is really very important. One of the papers that I was reading on negotiation was that it said that for each requirement, you decide that you have multiple strategies. Either you will have a win-win strategy, or you will have a win-lose or lose-win strategy. So basically, they're coming from the end user and maybe from your point of view as a requirement analyst. So for example, what would be a win-win situation? That I think that a certain requirement should be placed here, and the client also thinks that this is the same. So this is a win-win situation. And at times, I might have to agree with the client, and at times client might have to agree with me. So from my perspective, it would be a lose-win and win-lose situation, respectively. So this is very important to understand that as a negotiator, you give something and then you take something, and it is not always possible that you win all the situations. So you need to give a client the feeling that okay, you are also listening to what he wants, but you also want to emphasize on the importance of your opinion as well. So this is really important, that you have limited resources, and we want client to be happy, obviously, as well with what we are negotiating with. So it is really important to understand what kind of resources we have and coming to a consensus based on those things. So as we said, requirements are usually ranked, that is, they're prioritized by the customer, users, and other stakeholders. So there are different people who are involved in this process. When you're prioritizing requirements, you take all their opinions. And why prioritization is difficult? Because there are so many people involved, and we discussed this in the last lecture as well, that if there is just one person whose opinion actually matters, and there is just one client, and for example, it's just me, I'm developing my own software and I'm going to publish it on, for example, I'm developing an application, I'm going to publish it on a particular app store. And if it's just me, then I'm the one who needs to decide what is the order of the features that I have to build in my product. So prioritization is not a problem. But let's say I have another partner, and now there are two of us, and now there is a conflict because maybe there is this other guy who wants things to be done in a different fashion. So we need a mechanism to actually figure out that which things to be done first, and this problem would increase if I increase the number of people whose opinion actually matters. So we need to involve all these people. And why they come up with different prioritization? Because all these people may have different priorities and they might have different viewpoints. So for example, I would be of the opinion that these features should be done first because I want to release the product on a certain date, whereas the other guy whose opinion also matters, he comes in and he says, no, the prioritization order or the rank of the requirement should be different because he is of the view that quality should be built into the product. So there can be different perspectives from which people are coming from, and that's why they come up with different prioritization of requirements. Then, as I said, the risk associated with each requirement are identified and analyzed. So you try to figure out, okay, what are the problems that can happen in a particular scenario. If you, for example, I have to access the GPS location in my application. So for example, let's say that one of the possible risk is that that I'm not able to get that GPS location, for example, or the network is down, for example, the GPRS network is down, or there is no 3G available in the premises. Then my application, that's a very risky situation, and I need to think about that, how I'm going to go about it. Similarly, then we also, the next thing, as I said, we try to do an impact analysis, and this is not very exact impact analysis. That's why it said that rough guess of development efforts are made and used to assess the impact of each requirement on project cost and delivery time. So when you are writing requirements, it is not very exact, but you have an overall cost estimate. So what you try to do, you try to say, okay, roughly, this is going to take this many months to actually, or this many number of days to actually complete this particular feature. Then, as I said, that we have an iterative approach, which is reconciliation, and we use this iterative approach to come to a consensus. And within this iterative approach, we do multiple things. We either change or modify requirements, we either delete requirements, or we say, okay, we need to do some more elicitation, and we need to get some more clarification from different people, and we need to develop our own understanding, increase our own understanding about this particular process. So in terms of requirements engineering process, we started off with inception. Then we said we elicit requirements, and this problem of negotiation, it starts with elicitation, because we need to elicit requirements from multiple people. And there are processes in an organization. Imagine a very big organization, and as we discussed a lot of time, the example of learning management system in a university, and we discussed a particular process, which is the registration process, or the course registration process of the students. Now, two stakeholders which are very obviously involved in this process are students and the administration. Now, if I ask students, that how this process should be, or what should be the requirements that needs to go into this particular process, and if I get their scenario, they would give, their particular opinion. But when I talk to administration, they would give their opinion. Now, it's the same process, but because I have two viewpoints, the conflict is natural. So there is going to be always a conflict between between different viewpoints. So that's where this negotiation problem actually starts, because we get those conflicts at elicitation stage. And we said that at times these conflicts are not very obvious, because all we have at the stage are interviews. For example, we conducted interviews from students on one particular day, and after a week we went and talked to administration about this particular process, and we had two different viewpoints, but we gather them at different times, and they are written separately. So that's why we need an analysis and elaboration process, that we need to develop an understanding that what these viewpoints they said about this particular process. So we look at those different user stories, and we figure out, okay, no, they are actually talking about the same process, and what they want is that a student wants the registration to be done automatically, maybe, and the administration wants it should be done manually by students or something like that. So these things they're really important to clarify, and that's why we do this analysis, because when we are doing analysis, as we said, that in analysis we gain more understanding about the information domain, we gain more understanding about the functionality, and we gain more understanding about how the system should behave to achieve certain functionality and these kind of things. So when we do this elaboration and we increase our understanding, we are in a position now, because we have developed more understanding about the product. Now we can go and talk to the client that we think that this process should be done in this particular fashion, because if it's done this way, then it would be better for you as well. So that is how we should talk to the stakeholder, that we need to give him a picture where he's actually winning. So this is really important to understand. So this is where negotiation ends. And now let's say that we have reconciled all the requirements, and we have come to the consensus, everybody is happy. Now we are at a situation where we can start the specification. So specification is about writing these requirements. And this is what we are going to talk about today, that what is this specification process. But let's quickly go back, because we are going to specifically talk about writing functional requirements. Let's look back at the definition of requirements that we discussed in our initial lectures. So what is a requirement? It's a description of how the system should behave, or of a system property or attribute. Okay, so keep these things in mind. And these descriptions, they might be a constraint on the development process of the system. So it can be a constraint as well. We can either talk about how the system should behave or a certain feature of the system that we are talking about. For example, what are requirements of a user level facility? It might have a requirement: word processor must include a spell checking and correction command. Similarly, a very general system property can be: the system must ensure that personal information is never made available without authorization. And a specific constraint on the system, it might look like this: the sensor must be polled 10 times per second. And a constraint on the development of the system might be: the system should be developed using C# or C#. So if we look at these, this just gives us a feeling that that requirements are expressed at different levels. So there are few user level requirements, then we have some system level requirements, then we have certain constraints on the system, and these constraints are also divided. For example, we might have certain constraints on how the system should be developed, or we have certain constraints on the functionality of the system. So for example, as we can see here, that a user level requirement might be that you are developing a word processor, so you're saying, okay, spell checking should be built into it. So this is a user level requirement. Then we have a journal system property that no personal information should be leaked or given to anybody without proper authorization. Then we have a system constraint which says that if there are sensors deployed in a particular system, then they should be polled after a certain amount of time. Then we have a development process constraint where we are saying, okay, the system should be built in a particular language. So this is how these requirements are. But if you imagine that we cannot actually go straight from elicitation to specification, because what we have at elicitation is just user stories, and we need all those steps. We need to analyze them. Because when we do analysis, remember the use case example of the ATM machine. Now, a scenario was that a user goes and he is trying to withdraw cash. So he enters his card in the ATM machine and he withdraws some cash. So this was just a scenario that user told us. And if you remember that use case example that we discussed in a lot of detail, that when we wrote that use case text, we identified lots of different requirements, and those requirements were not only functional requirements, we also identified some non-functional or performance requirements. So specification. So there is a reason why this specification is placed here. So I would go back to that particular requirement, which is our main software requirement engineering process requirement. So we are here now. So we are at the 5th sub process of the requirement engineering process. We have talked about inception. So this was inception, this was elicitation, this was elaboration, and this was negotiation, and now we are here at specification. So this is the 5th sub process of the requirement engineering process. And as we all know, and we have been discussing it over and over, that these processes, they might look sequential, but they're not sequential as such. So we might start different things in parallel. Okay, and we can go back to different stages, as we saw that we can go back from negotiation to elicitation as well to a certain extent. So this is where we are with the software requirement engineering process, that we want to specify requirements. So just a bit more on the requirements. The requirements therefore invariably contain a mixture of problem information, statements of system behavior and properties, and design and manufacturing constraints. The primary measure of success of a software system is the degree to which it meets the purpose for which it was intended. So it is very important that we specify everything and we have everything written down. So specifying requirements is very important, because one of the main work products of the specification process is the software requirement specification document, and that document is used throughout the life cycle of the product, or maybe at least until you get your system validated and accepted and deploy it at the client's end. So for example, what you would have this SRS document. You will use it to design the system, you will use it to write test cases of the system, you will use it when you are developing the system, you are going to use it when you go back and get your system validated with the client. So this writing requirements in a proper fashion and at the right amount of detail is very, very important. So what are these functional requirements? So before we actually get to it, it's important that we talk about this specification as a process as well. So now we know what we have here with us. So we know we have lots of inputs. So we know we have lots of these requirements with us. We have elaborated on them, and we have a final list of negotiated requirements with us now. But when we are saying we need specification, now specification is about putting structure to these all these requirements. Through elaboration and through analysis, we have identified that which requirements are similar, how these requirements should be grouped together. But now it's time to properly and formally write, or properly specify, not formally, properly write these requirements in a document, and that's what we do. So one of the main work product of this specification process, as I said, was the SRS document. And within this specification process, there are lots of things that we do. And one of the things that we do when we are specifying requirements is writing these functional requirements. So before we actually talk about this particular activity, we need to understand that what are these functional requirements. So what are functional requirements? What inputs should the system accept? So this is one category of functional requirements. What outputs the system should produce? What data the system should store that other systems might use? What computations the system should perform, the timing and synchronization of all these things, of all the things that are mentioned above. So these are all part of the functional requirements. So for example, in order to register a course, so what are examples of the inputs? So for example, a student wants to register a particular course, so he enters his information, for example, his name, his roll number, or he enters his ID and password, and the main page of the portal opens up, and then he starts selecting these courses. So all he is inputting to the system, these are all functional requirements. So we need to mention that what are the inputs, or what kind of inputs my system should expect. Similarly, what outputs the system should produce. So for example, when a student submits the registration button, then what should appear? So what should be the output of my system? That is also expressed as a functional requirement. And what data needs to be stored? For example, for each student, we need to store his information. We need to maintain a profile of every student, and we need to have certain tables in our databases which are meant to store student information. So this is also functional requirement. Then what computation the system should perform? For example, we need to generate a report that how many students have registered a particular course. So in that case, our system might have to perform some computations. Similarly, in order to authenticate a student, we need certain computation that, so that is also part of it. And then the timing and synchronization of all these things, that is also part of these functional requirements. So next question is that how much detail should we go to? So this is very important. For example, when we are expressing those functional requirement of authentication, then this is a very good example that there are lots of small things which are done when we are authenticating a user. For example, there are lots of checks, small checks, that let's say there are two particular fields that a user can enter his login name and password. So these are the two things that user has to enter. Now, should we write a separate requirement that this field should not be empty, or and the password should be correct, or should we just express this as one functionality? So this is where it comes in, because there are a number of ways in which this thing can go wrong. For example, if a user enters correct password but enters incorrect login, then the system should not log in that particular user. Similarly, if the login is correct and the password is incorrect, it should not let, if these two fields are empty, system should not allow anybody to log into the system. Similarly, if one of the fields is empty, system should not allow. So there are lots of permutations in this particular computation. But what should be the detail of the functional requirements that I put in my software requirement specification document? So abstract requirements are the requirements of the stakeholders. Detailed requirements are a system specification. So normally when the client expresses something, then that he expresses at a very abstract level. And again, I would go back to that particular ATM cash withdrawal example. Now that was a very abstract requirement, because if you guys remember, we went into a lot of detail. For example, we said that a user might say that one of the scenarios is that a user withdraws cash. Now that's it. That is a very abstract requirement, and that is a requirement which is given by the stakeholder. Now, I cannot just specify that and be done with it. Because if you guys remember, we analyzed it and we identified lots of different things here, that whenever a user has to withdraw cash, he needs to authenticate himself first. So first is authentication, then maybe selecting a particular language, and then selecting a particular transaction. So there are lots of small different things that our system should do in order to actually complete this particular thing, which is withdrawing cash. So when we are specifying requirements, we need to actually go to that level of detail. So we need to identify that if there are any small things, or remember these 5 criterion, that If there is any input, that's a functional requirement. If there is any output, that is a functional requirement. If we're storing some information, that is a functional requirement. If there are certain computations going on, that is a functional requirement. So for example, in that particular scenario, withdrawing cash, there are certain inputs to the system. For example, the PIN number that the user is entering, that's an input to the system. Similarly, the output, the messages that are being displayed on the ATM machine, they are examples of output. And we're storing some information about the user. For example, we are going to contact the bank server because there is where the system information or the user information is stored, and we need to access that in order to ensure that the user has right amount of money in his account which he is requesting to withdraw from the ATM machine. So from a very abstract requirement, we analyzed it and we understood that what are the detail, or what are the details in this particular requirement, what data is involved, what functionality is involved, and when we are specifying, we talk about all those things in specification. Mainly there are two types of requirements. We have these user requirements and we have system requirements. So what are user requirements? Statements in natural language plus diagrams of the services the system provides and its operational constraints. They're written for clients. Then there are system requirements, a structured document setting out detailed description of the system functions, services and operation constraints, defines what should be implemented, so may be part of a contract between client and the contractor. So this is very important to understand that there are two levels of writing these requirements. We're saying that we have some user requirements where we draw certain diagrams or we write some text about it and we show it to the user or show it to the end users. But then there are system requirements where we write explicitly or in a very structured fashion. We try to specify that these are the functions that the system should provide, these are the services that the system should have, and these are the constraints on the system. And as I said that usually when you're signing off requirements, you normally sign off this particular SRS document because that is a contract between you as a software development team and the client. So these are the two levels. So let's look at the comparison of a user requirement and a system requirement, and we discussed it briefly as well with the ATM that level of abstraction and detail, you can actually see the difference. That the user requirement is that the system shall generate monthly reports showing the cost of drugs prescribed by each clinic during the month. So for example, we are talking about maybe a pharmaceutical company, and what they are interested in is seeing that how much of a particular medicine is being prescribed by different clinics. And now this is what maybe different stakeholders said that this is something that we want. But in order to actually do that, the system should have lots of small things built into it. So the system should store lots of information. System would have to perform lots of different functions to actually get to this particular point. So when we are expressing or when we are specifying requirements, what we have is, let's look at this particular example. So let's say we have 1.1 which says that on the last working day of each month, a summary of drugs prescribed, their cost and the prescribing clinics shall be generated. Then we are putting some constraints on it that the system shall automatically generate the report for printing after 5:30 p.m. on the last working day of each month. A report shall be created for each clinic and shall list the individual drug names, the total number of prescriptions, the number of doses prescribed, and the total cost of prescribed drugs. If the drugs are available in different dose units, for example, 10 milligram, 20 milligram, etc., separate reports shall be created for each dose unit. Access to all cost reports shall be restricted to authorized users listed on a management access control list. So you can actually see the difference, that this is what the user may be requested, but when you started implementing and you started understanding this particular user requirement, you said no, okay, there are lots of things that we need to do because we're talking about that we have lots of clinics who may prescribe medicine, so we need a clinic-wise data. Okay. So we put some constraints on the system that this report should be generated on the final day of the month when the business when the timing ends. For example, 5:30. Let's say you close the business, so this should be done automatically on the last day of each month, or last working day of each month. And then you're saying that, you want this report for each particular clinic. You not only want to specify that which drug is prescribed, but in which quantity it is prescribed and what is the dosage of that particular prescribed medicine. And then you're also limiting that all this information, it should be limited to only authorized users. So not everybody who works in this company should be able to view these reports, but only authorized users should be able to view this particular report. So you can see that the level of abstraction that when we are specifying these requirements for the users, they are very abstract or at a very higher level of abstraction, whereas when we are talking about system requirements, then they are very, very detailed. And who are the readers of different types of requirement specification? So user requirements are client managers, they may be interested, system end users, client engineers, contractor managers, and system architects. They would be the people who might be interested in these user requirements. Whereas who are the people who would be interested in these system requirements? So system end user, the client engineers, system architects, and software developers. These, you can see the difference that here, this is the key difference here, that developers are also coming into play, and we also have client here as well, and we have end user as well, because we said that this is used as a contract between you and the client. And you also give this detailed specification to your development team, to your designers, to your architects and to your developers, because you tell them that, okay, when you are designing a system, you need to not only look at the user requirements, but you need to look at this, low level of abstraction as well, because in reality, all the big functionality that we want is a mixture of, these small things. So we need to identify that who are the users. So generally we say that for a user requirement, we have client managers, system end users, client engineers, contractor managers, and system architects, whereas for system requirements, we have developers, architects, system end users, and clients, engineers. So because we want all these things to be connected together, so we saw that we used use case to analyze requirements in a specific kind of analysis approach, which was object-oriented approach, and within that scenario-based modeling had use cases. So let's look at how we derive these requirements from a use case. So this is an example use case, and this is a particular example of a sign up. So user is signing up to a particular application. So let's try to identify that. Let's go through this particular use case. That we have this use case ID, we have the use case name written here, then we have actors, which is the application user, and we have the Gmail server, which is maybe a secondary actor, and then we have this description that user is signing up to get registered and to get backup of his or her history on the cloud. And the user selects the application icon. So user is basically kind of selecting a particular application icon. This is the trigger when this, for example, the user is using this application for the first time, and he clicks or taps on this particular application. And so what are the preconditions? So that is the trigger. So what is the precondition? That user has downloaded this application successfully. So let's say you have downloaded recently an application from an app store, and the first thing that you would have to do in order to use this particular application is to sign up. So that is the first use case, or the first usage scenario, that you are tapping on that particular application icon, and the precondition is that you have successfully downloaded that particular application. So the post condition of this is that user is successfully signed up and login information is stored on the phone. In future, the user should be logged in automatically. So if you most of us are smartphone users, so even if you're not a smartphone user, and if you install a particular application on your computer, then you would see that normally an option is given that whether you want the system to store your username and password. If you want this feature to be built into your product, that you want to give user a feel that if you have already entered your information, you do not need to do that again and again. So maybe you can have that. So your post condition would be different. So in this particular case, we are saying that application would store that information and user won't have to do that again. So we are saying that user is successfully signed up and login information is stored in the phone, so you do not have to enter this information again. So then the next part, if you remember the use case text, we have these normal flows. So we are saying that user selects this particular application, which is prayer assistant, and then your system asks for Gmail ID, password, and other details, and the user give Gmail ID, password, and sect. System will confirm email ID through Gmail server. System stores information. System displays a confirmation dialog to give feedback that the user is successfully registered. Then we had another section within a use case where we used to identify the alternate flows. So in this particular example, in the step 4, we have an alternate flow. So we are saying in step 4 of the normal flow, if the user entered wrong email ID. So if the user enters a wrong email ID, then what would happen? The system will display a warning message. Email ID does not exist, and the system will ask to re-enter this email ID. And the use case would resume on this particular step again. So use case is going to resume. So there would be these actions would take place, and then the user is going to come back here. So in this particular example, we have not written any exceptions, and there are no includes, there are no special requirements, but we have an assumption that as to download application from Google Play Store, user must have a Gmail account. So we are assuming it is an Android application, and we are downloading it from a Google Play Store. So a user should have a Gmail account. And that's why we have this assumption of authenticating with the Gmail server. So this is the use case, and now we have to see that how we are going to derive our requirements, because we are specifying requirements now. So how we will derive requirements from this particular use case is that the first thing is the user shall download the mobile application through Play Store. The system shall display sign up from form which takes Gmail ID and password and sect as input. The system shall verify the user's provided account exists at the Gmail server. The system shall display a warning message in case the email ID does not exist or it is incorrectly entered, and should also display that re-enter the email ID. The system shall display a confirmation message to give feedback that user is successfully registered. Now imagine, that at the user level we are saying that a system should have this sign up functionality. But within that sign up, there are so many small things involved here. We are saying that that system. First of all, we need to make a form which actually displays, lets the user enter some input, which is his Gmail ID and his sect and the other details. Then the system should be able to talk. There is a computation involved, that the system should be able to go and talk to the Gmail server and see if the address entered is valid or not. In case it's not valid, the system should display a different output. If it's valid, the system should say, okay, congratulations, you have registered to this particular application. So this is how we derive applications from a use case. And now we can actually think that all this analysis that we go through, it was not only useful for negotiation, but it is also useful for getting to a lower level of abstraction and actually being able to specify those system requirements. So what are characteristics of a good SRS? We have briefly, or we have actually talked about that in our earlier lectures as well, that the requirements should be correct. So this is something that we ensure, because, and that's why the specification process is placed after negotiation, because we want to specify requirements which are correct, which are unambiguous, which are complete, and which are consistent. And they are also ranked for importance and for stability. We have also talked about it, that when we prioritize after negotiation, we get a prioritized list of requirements, and we have ranked the requirements and this rank, the final rank, is something with which all the stakeholders, all the clients, and all the end users, they're happy. And these requirements, they should be verifiable. This is also very important, that requirements should be expressed in such a fashion, as I always say, that requirements should be quantitative. So if I put a certain kind of a performance constraint on something, then it should be quantifiable so that I can actually verify it in the end. The requirement should be modifiable, it should be traceable. So generally, when we say we are expressing requirements, and when we are specifying those system requirements at a lower level of abstraction, we should think that each requirement is correct. It should not be ambiguous. It should be complete, consistent, and it should take care of all these features or all these characteristics. So how do we say that a requirement is correct? An SRS is correct if and only if every requirement stated therein is one that software shall meet. So we should not be writing or specifying requirements which nobody has actually asked for, and we just think that this is something useful for this particular client. So we should only specify requirements which are within the boundary of the system. There is no tool or procedure that ensures correctness. So this is something that you do through your experience or personal judgment. You identify that whether a certain requirement is correct or not, and that is why, as such, there are different metrics which are being made for identifying these correct or incorrect requirements in terms of when you are checking the quality of your SRS. But there are no tools which can actually measure or gauge that whatever you have written is whether it's correct or not. The SRS should be compared with any applicable superior specification, such as a system requirement specification, with other project documentation and with other applicable standards to ensure that it agrees. Alternatively, the customer or the user can determine if the SRS correctly reflects the actual needs. Traceability makes this procedure easier and less prone to error. So there are different ways of actually ensuring whether your requirements are correct or not. You can go back and look at another project documentation. You can go back and talk to the client and ask him that, okay, whether this is what you want or not. And also you have this traceability, which we're going to talk about in our next lectures. That is also useful for ensuring whether your requirements that you have expressed are correct or not. Then what is an ambiguity, or what are unambiguous requirements? An SRS is unambiguous if and only if every requirement stated therein has only one interpretation. And I don't know whether we defined it earlier or not, but we have used this word quite often in this course so far. That ambiguity means that, you know, as you have written something and you have written about one process in two different instances, and each one of those instances, they convey a different meaning. So that means that, you know, whatever you're writing is actually ambiguous. And as a minimum, this requires that each characteristics of the final product be described using a single unique term. So this is very important that, you know, for example, we are talking about the registration process. Now, the requirements about the registration process, they should be put together. Okay, first of all, they should be put together, and when we are putting them together, we will identify, okay, there are ambiguities in these two statements, because one of them came from one stakeholder, the other came from a different stakeholder, and that's why we did that negotiation to actually resolve those problems. So by this time, when we are specifying requirements, all the requirements should be unambiguous, and we should use consistent terms when we are discussing a particular functionality or a feature. The SRS should be unambiguous both to those who create it and to those who use it. So this is very important. It is not just for the requirement analyst, but there are lots of users, as we have identified in our previous slides, that we have the users from the client side, we have the user at our own site. For example, we have developers, designers, and testers. They're also going to use it. So we need to put terminology in the SRS which is readable and understandable for all the people, not only the people who made it, but also for the people who use it. And this is something which we discussed in our earlier lectures as well, that a requirement document is written once, but it is used throughout the product development life cycle. And you know, you just are going to write it, but lots of people are going to use it. So that's why it should be written in a fashion that it is completely unambiguous. So we say that, you know, it is ambiguous. It should be unambiguous for all the different people who are involved with this. And why I've emphasized that, you know, that the people they come from different backgrounds, and therefore they do not tend to describe software requirement the same way, because, you know, a tester may look at a certain requirement in a different fashion, and a developer, he might have different sort of an experience, and he would be thinking about a particular feature in a different fashion. So we should ensure that whatever we are writing, everybody thinks about this particular requirement in the same fashion. So how do we actually avoid this ambiguity? There are natural language pitfalls. So for example, you know, we need, normally these requirements are expressed in natural language, so we need to ensure that we use the words which are not ambiguous. There are certain requirement specification languages. We are going to discuss a few, and then there's a representation tools. That's why we normally annotate our requirements, or this SRS document. In appendices, we try to attach different diagrams we make, and the reason is that we try to reduce the ambiguities because they are natural, because of the natural language in which they are expressed in, and they are inevitable. So either we write requirements in different requirement specification languages, as for example we may use a formal language, but there are pros and cons of it. The advantage is that when we express requirements formally, there are no ambiguities, but the expense is that it is very expensive to write these formal requirements, and normally you don't find a lot of people who can express requirements formally. So you can also have lots of these representation tools which are useful for interpretation of requirements. Then how do we define that our SRS is complete, or all the requirement that you have written is complete? So we say that an SRS is complete if and only if it includes the following elements: all the significant requirements, whether relating to functionality, performance, design constraints, attributes, or external interfaces. So definition of the responses of the software to all realizable class of input data in all realizable classes of situations. So it is important to specify the responses to both the valid and invalid input values. So this is very important, that when we are specifying requirements, and so we cannot say our SRS document complete if we are not telling the responses of our system based on the invalid input. So as I talked about that particular login example, or we looked at that sign up use case, that if a user enters an incorrect Gmail or an email ID, then when we authenticate with the Gmail server, we should show our client a message that you have entered an incorrect email ID. So that is how, that only then we can say that our SRS is complete. If we just think about the normal flow of events, then our SRS cannot be complete because user can enter an input incorrectly as well. So full labels and references to all the figures, tables and diagrams in the SRS, and the definition of all the terms and units of measures. So normally, whenever you are writing an SRS document, it is very important that you cross-reference all these things. For example, if you have expressed a particular requirement from a certain use case diagram, then maybe give a reference to that okay, go and look at this particular diagram, so that if there is any ambiguity, then a user of that system should go and actually look at that. So cross-referencing should be there, and if there are certain application domain knowledge which you have put there, and there are certain computational requirement for which uses certain figures which nobody understand other than the guys who actually do that. So your developer might not be able to figure out what that unit of measure is. So you should be able to, you should have a section where you actually explain that what this unit of measure actually means. So normally you have a list of acronyms section in your SRS document where you try to list all these things which are unique to this particular document that you're producing. So how we define consistency of an SRS document? So an SRS is consistent if and only if no subset of individual requirements described in it conflict. So there should not be any conflicts, and if there are no conflicts, then we say, okay, our SRS is, or all the requirements that we have written, they are consistent. There are three types of likely conflicts in an SRS, which are as follows. The specified characteristics of the real world objects may conflict. Okay. So for example, the format of an output report may be described in one requirement as tabular, but in another as textual. So that is one sort of conflict, that your real world objects, so for example a report that you are going to generate, one person says that okay, this should be expressed in the tabular form, the other person says no, it should be expressed in the textual form. And one requirement may state that all the lights shall be green, while another may state that all the lights shall be blue. So you have some real world entities which are part of your system, and different requirements are saying different things about them. So that is one kind of a conflict. There may be logical or temporal conflict between two specified actions. For example, one requirement may specify that the program will add two inputs, and other may specify that the program will multiply them. Okay. So again, this is some logical conflict. This is not a conflict between an object, but this is a logical conflict because there are two inputs, and at one instance, one requirement is saying that we are going to multiply them, and another instance we are saying we are going to add them. Another example is that one requirement may state that A must always follow B, while another may require that A and B occur simultaneously. So again, when you give this to a developer or a designer, or you show it to a client, there is conflict. Okay, what should happen? So two or more requirements may describe the same real world object but use different terms for that object. So there can be difference in how that object appears, but there can be difference in what kind of terminology is used. So for example, a program's request for a user input may be called a prompt in one requirement and a queue in another. The use of standard terminology and definitions promotes consistency. So we have seen that there are three kinds of conflicts that can occur, and if we identify those conflicts between requirements, we will identify what are the consistency problems, and if we resolve all those conflicts, we will say that our SRS is consistent. So the first type of conflict that we have in our requirement is that the characteristics of the real world objects may conflict. So as we have seen that we have seen example of a report, and we have seen example of maybe some lights, that a report, in one instance, in one requirement, you're saying that this particular report should be generated in a tabular form, and in another instance we are saying this should be generated in a textual form. And there can be logical or temporal conflicts. For example, we are saying that a certain activity or a certain process should follow another process, where we are saying that they are occurring simultaneously. And then finally, we are using different terminology for the same real world object. For example, we are saying that a prompt would take the user input, and other instance we are saying the queue for the user input. So it is very important to use consistent terminology and consistent throughout your SRS document. So this is how we define that an SRS is consistent or not, by identifying conflicts in the requirements. And then we have verifiable. How do we say that an SRS is verifiable? So an SRS is verifiable if and only if every requirement stated therein is verifiable, obviously. our requirement is verifiable. So we are saying that, you know, our SRS would be verifiable if all the requirements are verifiable. And how do we say that each requirement is verifiable? So our requirement is verifiable if and only if there exists some finite cost-effective process with which a person or machine can check that the software product meets the requirements. So verification very simply means that, you know, if you have said that, you know, your system should have this particular, for example, you know, you're saying that a user or that particular sign-up functionality, for example, now that is a verifiable functionality, because all the small requirements that you have identified, that, you know, you are going to go back and check with the Gmail server, so you can actually verify. For example, if a client wanted this particular application and we developed it for him, so when he is testing this particular application, he is going to check all these requirements. So he is going to say, okay, I'm going to enter an incorrect email ID and see what the system does. And if and this is a verifiable requirement, because I'm going to enter an incorrect email ID and I should get the response. So this is a verifiable requirement. Whereas if I say that, you know, system should have good authentication process in place, and I don't actually specify what is the good authentication process, I do not mention that system should should in particular look for the Gmail ID or talk to the Gmail server, then actually I have not put limit on it. So there is no actually definition of this good authentication process. So all my statements, they should be written in a fashion which are verifiable. In general, any ambiguous requirements, if there is any ambiguous requirement, then it is not verifiable. Non-verifiable requirements include statements such as works well, good human interface, and shall. You know, all these statements, they shall usually happen. You know, all these statements, they put ambiguity into a requirement that you write. And whenever there is ambiguity, then that requirement is not verifiable. As I give you the example of good authentication process, or it should, you know, have good quality. You know, that is not a verifiable statement, because quality is a subjective term and it would mean different things for different people. So when we are talking about quality of a product, so we try to mention quality in different terms, in terms of performance, in terms of reliability, in terms of safety, and we try to quantify them. The reason why we talk about quantifying these requirements is because we want to verify requirements. Because there should be a procedure in place with which the end user is going to say, okay, this is what I wanted and you have given me this, now I'm going to test this. And this verification process actually demands that all these requirements, they are verifiable. So these requirements cannot be verified, all these examples of works well, good human interface, and shall usually happen, because it is impossible to define the terms good, well, and usually. The statements that the program shall never enter an infinite loop is a non-verifiable, because the testing of this quality is theoretically impossible. So again, whatever we express in our SRS document should be in a fashion which is testable. So when something is testable, if you can test a particular requirement with, you know, some real world resources that you have, then you can say, okay, this is a verifiable requirement. So all the requirements that you write in an SRS, they should be verifiable. Then finally, you know, there are other characteristics of an SRS, that all your requirement, they should be modifiable, they should be stable, and they should be traceable. So the requirement should be expressed in a fashion that, you know, they can be modified. So there is so until the requirement document is baseline, there should be allowance that requirement can be modified. And similarly, the requirement document should be stable. You know, it should not happen that you change this particular requirement every now and then. And the requirements should be traceable throughout the system. And we are going to talk about these things. And for example, we are going to talk about this traceability of requirements when we talk about requirements management in particular. So these are generally the characteristics of an SRS document, or when we are specifying requirements. So I think this is where we are going to end our today's lecture, and we are going to continue from here, and we're going to look at some examples that how we specify these functional requirements which are consistent, which are complete, which are verifiable, and which are not ambiguous. So let's quickly look at what we have done in our lecture today. So in our lecture today, we started with and we concluded our discussion on the negotiation process, and we looked back at what are the different activities in negotiation process. We said that generally the negotiation process starts with prioritizing or ranking the requirements, and then we do a risk assessment, then we make guesses of the development time, rough guesses of the development time of each requirement, and finally we start an iterative process where we reconcile all the conflicts. And the understanding is that once we have gone through this negotiation process, we have reached a consensus, and now we are ready to start specifying the requirements. And Then we started our discussion on the specification process, and just to give just to be up to speed again, we briefly discussed that what is a requirement, and so we said that it can be any system property, any feature, or it can be any constraint on the system as well. And then we said that what are the different types of requirements, and within those type of requirements we said that there are mainly two types of requirements. There are user requirements, and then there are system requirements. And we basically said that these two kind of requirements, they are expressed at different level of details. So the user requirement, they are very abstract description, and this is a detailed description, the system requirements. And we looked at particular example and we talked about this particular example of the ATM cash withdrawal, and we said that that was just an abstraction, whereas when we are going to express this particular requirement, then we are going to put in a lot of detail. And specifically we looked at the example of how we can derive requirements from a use case, and we looked at the example of a sign up use case, where we said that a user might say that this particular application should allow new users to sign up, and but this is just a very abstract description of a very detailed system functionality. And through our analysis, which we have done through making a use case, we have identified different normal flow of events and different alternate flows of events. So what we are doing now here is that we are going to look at that particular use case, and we'll specify different requirements. So the first requirement can be that the system, that application should be downloadable from an app store. Then the second functional requirement may be that the application should provide a form where user can enter different information. Then the application should be able to authenticate the user from the different from a particular server, which was in that particular example Gmail server. Then the system should display appropriate messages based on if the email ID is correct or incorrect. So we saw that how from a very abstract definition of a requirement, we go to a very detailed description of the system requirement. And we also specified that there is a difference between who is going to use what kind of requirement. So when we talk about the system requirement, they are intended more for, they act as a contract, because everything is written in at a very detailed level. So we want to express these requirements in a fashion which are verifiable, which are consistent, so that the client also sees, okay, that this is what I am going to get. And so you actually sign it off, and that's why it is used as a contract as well. And it is also used by your own team. So for example, you as a software development house is going to use, and different people in your company are going to use it. Maybe requirement analyst made it, but system architect, they are going to use it, designers, the testers, and the developers, they are going to use this particular document. And finally, towards the end of the lecture, we talked about something which is very important, that which is characteristics of a good SRS. And again, what is an SRS? It is a software requirement specification document, and it is the main work product. So this is the work product of this specification process. And it is a very important document, a software requirement specification document, and this requirement engineering, it actually revolves around producing this document and maintaining this document, and making sure that this document is up to date and all these kind of things. So when we are expressing or making this software requirement specification document, we need to ensure of certain things, and there are certain characteristics we talk about. We said that the requirement, it should be complete, it should be correct. The requirement written, they should be consistent, they should be verifiable, and they should be unambiguous. And we specifically looked at all these things, that what is meant by complete requirement, what is meant by correct requirement, what is meant by consistent and verifiable and unambiguous requirements. And some of these things, they cannot be measured. For example, we cannot measure that, or we cannot actually see lots of these things. Actually, they are done through expert judgment. That you look at the requirements, and you, for example, you cannot actually measure correctness. Okay, and similarly, you can identify, there cannot be any tool to actually tell you that which requirements are unambiguous if they are written in a natural language. So we said that there are different ways of avoiding these conflicts and avoiding these unambiguities, or making sure that the requirements are verifiable. For one solution was that you express these requirements in different requirement writing languages. For example, you use a formal language to express your requirements, but there is a cost associated with it, which we're going to talk about further when we discuss formal methods of writing these specifications. So in general, these are the characteristics that we have talked about today, that what are requirements, what are the different type of requirements, what are different users of requirements, and what should be good characteristics of an or what should be the characteristics of the requirement that you write in an SRS document. In our next lecture, we are going to start off with some examples. We are going to look at what are good, how we say that this particular requirement is written is good or bad, and we are going to talk more about the specification process, and then we'll start looking at how we specify non-functional requirements. Because remember, we said that when we talk about specification, it's not only about writing those functional requirements, it is also writing those non-functional requirements. So that is it from today's lecture. Inshallah, I will see you in the next lecture. Take care.